Are you fed up with your messages taking ages to send over the internet? Or having your messages intercepted and read but with no evidence of it happening? Then you should try the new quantum internet. Instead of sending each bit of data in a message as a pulse of light that reflects on an optical fibre, where each bit of data is either the pulse or an absence of a pulse, we send each bit, or sometimes many of data, on a single photon. We do this by changing one or several of the degrees of freedom of a photon, which are properties we are able to change, such as its circular polarization, orbital angular momentum, or energy, which are each changeable properties providing another bit of information per photon. So, the quantum internet can transfer your signals over the internet in less particles than the classical internet, so your messages can be sent on distances up to 100 kilometers, about the same distance from London to Portsmouth. Unfortunately, we can't go further at the moment because we only send each bit of data once, instead of several times, as error correction methods like majority voting on the classical internet would. This is because of the no-cloning theorem, which proves that quantum data can only be sent at once or will no longer be completely secure. However, photons keep their properties very well until about past 100 kilometers, where they're too likely to have escaped the optical fibre to arrive at the receiver. But we're fixing this problem using CubeSats, which will send your messages around the world by using waves and satellites. Our signals are also way more secure than on the classical internet. In order to communicate safely online, two people need to share a key that only they have access to in order to encrypt and decrypt the transmitted data. However, sending this key is the most risky part of the transmission. On the old classical internet, it was easy for hackers to intercept this without getting caught because the waves of light in an optical fibre doesn't change when observed. However, using quantum key distribution, which is often abbreviated to QKD, it is impossible for a hacker to not get caught, and it's also impossible for them to observe the exact data being transmitted. This is because, when a photon is observed, things change. For example, by reading a piece of paper, a photon must have been absorbed by the sheet in order to produce light to make the paper readable, and this causes the paper to slightly heat up, making it possible to detect that someone has seen the piece of paper and read it. Photons changing their properties when observed was first found during the double slit experiment, where it was found that photons stopped passing through a slit if and only if it was being observed, implying that photons' properties change upon observation, which is one of the main properties of a photon. Not only does this catch any interceptions, but it also prevents the data from being taken. So why would you want to connect to the slow and insecure classical internet? Connect to the quantum internet today, or at some point during the future because technology is still being developed, in order to have a faster and more secure internet. Quantum internet, coming to one of many worlds near you soon. Awesome!